In the problem number 81, we have a capacitor of capacitance 100 microfarad is connected across a battery of 6 volt through a resistance 20 kilo ohm for 4 seconds. The battery is then replaced by a thick wire. What will be the charge on the capacitor 4 seconds after the battery is disconnected? The problem is a little bit of charging and then discharging. There is a charging of capacitor and then discharging of the capacitor. So it is charged for 4 seconds and then it is discharged. That is what is happening. So here is the 6 volt battery and at t time equal to 0. Let us say the switch is closed. So a current starts flowing and the battery starts getting charged. And this charging equation is given by Q is equal to Q naught 1 minus e to the power minus t by RC. Where Q naught, what is Q naught? Q naught is the charge that would have been on the capacitor had it been charged for an infinite period of time. That is the charge when the 6 volt would have appeared on this charge. And if 6 volts were there on this capacitor, the charge on this will be Q is equal to CV or 100 microfarad into 6 times 6 volt. So that is the Q naught. We got Q naught and then e to the power 1 minus e to the power of minus t. T is 4 seconds. So minus 4 divided by R is 20 kilo ohm. So 20 into 10 to the power 3 into C is 100 microfarad. 100 into 10 to the power minus 6. So 10 to the power 3 and 10 to the power minus 6 here becomes 10 to the power minus 4. 2 zeros go. This 10 to the power minus 2. 10 to the power minus 2 and then 3 plus 2 5 and there is 1 0 here. Those cancel. So 3 plus 2 here and 1. 3 plus 2 5 and plus 1 6 and 10 to the power minus 6. All zeros go away. So 4 divided by 2 is e to the power minus 2. So this is the charge on the capacitor after 4 seconds. Not what we do is we remove this battery and we connect it with the wire. So this whatever charge here we calculated is discharging through this capacitor. And the discharging equation is Q is equal to Q naught e to the power minus T by RC. And what is this Q naught? Q naught is the initial charge on that capacitor. And that is this whole term. 600 into 10 to the power minus 6, 1 minus e to the power minus t. And this term e to the power minus t of t by RC is the same as this term. So this is e to the power minus t 2. Now all we need to do is do some calculation to find out the charging on the charge, final charge on the capacitor 8 seconds after it is first connected. And 4 seconds after the battery is, the battery is replaced by a thick wire. So you can write it as 1 upon e square and e is like 1 upon 2.7. So we have done some calculations. E to the power minus t would be 0.135. That's all you need to calculate only e to the power minus 2. So this is 0.135 and this will becomes equal to 1 minus 0.135, which is 0.865. And if you multiply this whole thing, you get something like 70 microcoulomb. You can verify this.